Welcome. I am Philippe Mons, Assistant Professor in Mathematics Education at the Freudenthal Institute of Utrecht University. In this video, I'll show you how to calculate a generalization of Fleiss kappa, a statistic that measures agreement when raters can classify subjects in multiple categories. So one subject can be classified in either 0, 1, 2, or even more categories. I'll guide you through the calculation step by step using nothing more than Microsoft Excel. This video gives an intuitive explanation of the measure. No mathematics will be required. If you are interested in the full statistical details of this measure, you can find them in our paper published in Behavior Research Methods, co-authored with Professor Ellen van der Vieren. More concretely, I will explain you when to use the generalized Fleiss kappa. When do Cohen's and Fleiss kappa fail? How do you calculate generalized Fleiss kappa using Microsoft Excel? How do you interpret the outcome? And we'll have a look into further possible videos. So, when to use it? As I said, we use a generalized Fleiss kappa whenever we want to assess the inter-rate reliability, which in this case will be measured as an assessment of the agreement of different raters, classifying subjects into one or more categories. We now turn to our example. In the example, 3 independent raters, which means that they classified blindly so they don't see each other's ratings, will classify 4 subjects, which in this case are 4 tweets from famous American politicians. And they will classify these tweets into 5 categories, namely politics, economy, health, positive vibe, negative vibe. Note that our generalized Fleiss kappa only allows nominal categories. So categories are actually labels you can assign to a subject, like this tweet is about politics and has a negative vibe. But these categories cannot indicate any order or rank. So for example, categories going from good to bad are not allowed. So here we have an example of a tweet of Joe Biden. It's good for our economy and it's good for the millions of Americans who can't afford their medications. Rater 1 classified it as talking about economy, health and having a positive vibe. Rater 2 classified it as talking about politics, health and also as having a positive vibe. Rater 3 indicated economy and health. The raters also classified the other tweets, but we don't show them here. The Obama's tweet was rated by all as standing for health and having a positive vibe. The Trump's tweet was indicated to have a negative vibe by all raters and some also indicated politics or economy. And the Bernie Sanders tweet, well, on that, raters agreed that it was about health and has a negative vibe. Some also indicated politics or economy. So when do Cohen's and Fleiss kappa actually fail? Well, if we look at these classifications, we see that most of the time the raters selected multiple categories for each subject. This is not allowed for a normal Cohen's or Fleiss kappa. They only allow one category for each subject, so classifications will look like this. Moreover, for the Cohen's kappa, only 2 raters are allowed. So if you need to measure the agreement for raters classifying subjects into multiple categories, you actually really need our measure. So how do we calculate our measure? If we have all the classifications, we need to create an agreement table. The first row of this table is a tweet of Joe Biden, and we just count the number of times each category was selected for this tweet. So for the category politics, we see that 1 rater selected it for this tweet, so we put a 1 in this cell. Then we go to the category economy and we see that it was selected 2 times. For the category health, we see that all raters selected it, so we have a 3 in this cell. And then we go to positive vibe, we see that it was selected twice, so we put a 2 there. And then for the negative vibe, nobody selected it, so we have a 0 there. And we can do the same thing for the other tweets, which leads us to the agreement table of this example. With the agreement table, we are now ready to use the Excel add-in that we provide in the description of this YouTube video. So here is Microsoft Excel. To install our add-in, go to File, Options, then go to Add-ins, Manage Excel Add-ins, Go, Browse to the file you just downloaded, and then it is installed. So you just installed a customized function that will allow you to calculate the generalized Fleiss kappa based on an agreement table. Here I already prepared the agreement table of the example based on the ratings above, so of course you can also use Excel formulas to create your agreement table. And then we are ready to calculate our statistic. We use equal sign kappa. And then as a first argument, you give the range of the agreement table. As a second argument, the number of raters, which is 3 in this example. And then as a result, we get 0.49. So how to interpret that 0.49? Well, imagine you are running a race, not against a person, but against random chance. Random chance always gets a kickstart. Why? Because even if multiple raters are just guessing, like rolling a dice to classify subjects, they will still agree some of the time just by luck. The kappa statistic tells you how far you ran beyond that lucky agreement compared to how far you could have gone if your raters agreed perfectly. So if our kappa is equaling 0.49, it means we covered 49% of the possible distance beyond random chance toward perfect agreement. We are not at the finish line, but we are almost halfway there. And more importantly, the raters in our example are definitely not guessing. Sometimes the kappa becomes negative. That means that raters disagree more than you would expect by just random chance. And it actually means that you run in the wrong direction. In order to improve your kappa statistic, I would always advise you to calculate the kappas of the individual categories. So you just use the same function again, but as an agreement table, you now give the agreement of only the first category, and the number of raters stays the same, of course. And then you can use a fill handle to calculate it for all categories. And then we see there is actually perfect agreement for health and negative vibe. So these categories are really good. It's reasonable for positive vibe, but then for politics and economy, it goes below 0. So raters classified in these categories below random chance. So in practice, this actually means there is something wrong with your definitions of these categories. So it should be more clear when to use this category and when not to use it. So this actually means if you have a code book or something that you should revise it for these categories in order that the raters can classify it a bit more uniformly. And well, as a general rule of thumb, a kappa above 0.8 is considered to be really, really good and actually often even unbeatable. We are nearing the end of this explanation video, but the story of our generalized Fleiss kappa is far from told. In possible further videos, I might address some more advanced topics, like handling missing data. For example, some ratings of rater 3 might be missing, or not all raters classified all subjects because your dataset was too big. Also, handling weighted categories is a more advanced topic. For example, based on theoretical grounds, politics, economy, and health are seen twice as important as having a positive or negative vibe. Another more advanced topic is handling hierarchical categories. In this explanation video, we've treated all categories as flat labels like positive or negative vibe. But in reality, categories often have structure. In some cases, we don't just code negative vibe, we go deeper. A rater can, for example, select negative vibe for a tweet, but negative vibe can be further split into subcategories like frustrated, anxious, disappointed, and outraged. Even on a deeper level, frustrated can be further subcategorized in irritated and overwhelmed. For example, in order to select irritated, a rater first had to select negative vibe, next opted for frustrated, and only then we could select irritated. This means we have an hierarchical category structure and our method can accommodate these hierarchical categories. Last but not least, another more advanced topic is definitely bootstrapping that allows us to create 95% confidence intervals around our kappa statistic or do hypothesis testing, if you have two groups of raters and you want to compare them, who rated more reliable than the other, that's where we can use bootstrapping for. So this is the end of the explanation video. I thank you for your attention.